Hello and welcome to MLOps Minutes. So now in this episode, what we're going to do is automate as far as possible all the steps in the annotation workflow in order to make these steps industrial. So what we're going to do is we've got our PDF image extraction brick. And the idea is that once we've done this extraction, we'll want to version the data that comes out of this stage and automatically inject them into our annotation application. But what's going to happen is that our AzureML, we're going to be doing a lot of them. So the idea is that if the images at the end of this step don't change, we won't want to version this data if it's identical to the next experiments. And we won't want to re-inject them and re-inject the same data into this application. So we'll do this injection only if the output images of this step have changed. Come on, let's go. So the pipeline will look like this. I'll give you the link to the pull request at the end of the episode. What happens is that we find our extraction brick, which will extract images as output. What I've done is to add here another output directory, hash output, because what we're going to do is calculate the hash of the contents of all output images and save this hash in another directory, which we can then retrieve. Now, I don't know if you know what a hash function is. A hash function, what happens is that it's a non-reversible function. So we can have an input, we'll execute this function, we'll get a hash. If we always take the same input, we'll always get the same hash, and this hash won't change. But if we change the input, the hash will change. There is a risk of collision, but it's very small. So if the hash changes, it means that the data has changed. In this case, we know that we can take a different action. So what happens is that here at the code level, what I've added, it's the fact that we go to the .py command, which is the launcher. We extract the images as before. I've added a little file, as it's called directory hash, in which you can ask it to calculate the hash of all the files in it. And this hash will be saved in a hash.txt file in the output directory, which we can retrieve later. Next, I've created a second box here, output. This box will come in handy because it will allow us to extract a single directory as output, which will contain several directories, our output directories. So why did I do this? It's because I realized that if we record this extraction step, which takes about 50 minutes, directly in the output, and this step writes directly to a storage, and each time we have to write to a storage, AzureML won't cache this box and play it each time, which takes 50 minutes. In other words, what I want is to benefit from AzureML's caching system. You need to know that in AzureML, if the input here, the input dataset, doesn't change, and the code that executes the step here doesn't change, AzureML will display this little logo who will say, I'm reusing the caches. As a result, the execution of this box will take 0 seconds. As a result, this step output at the end of our pipeline will just copy and paste to aggregate all the data from all the steps that we want to receive as output. This one will be executed each time, but as it's just copying code, it's much faster. Here it took 2 minutes to copy 30,000 files, roughly 30,000 images. So it's more acceptable than 50 minutes. So much for the explanation. Now, I'm going to show you a little bit what's changed in the pipeline. Before, we save the input directory and run our pipeline here as mo-client.jobstream. What I added is an output directory. Here, we need to configure the output directory. I generated an experiment ID, i.e. for each experiment, we generated a new unique output directory with a guide. As a result, we save the output files that will be versioned in a storage folder. Here, and configure our output directory, which corresponds to the output. Here's our final output directory. What's changed is that we now run our job. So I forgot to show you the pipeline. So we do the extraction step and give my output step 2 parameters, extraction input and extraction images input. This output step is very simple. What does it do? It copies files from a directory one in the output in an extraction images directory, and our hash file will be copied and pasted into an extraction hash directory, and we'll find our hash.txt file. So once we've done that, I've created a little function here called register extracted dataset. It's here, it's special. What's it for? I've got a few things to describe here. It's going to allow us to download our extraction hash directory that we're going to upload to our task. We'll be able to retrieve the hash that corresponds to the hash of all my images. So that's interesting. Next, we'll want to create a dataset if this hash has changed. If it doesn't exist, if it hasn't changed, I'm not going to create a dataset. I'm going to pick up the latest number of the dataset, which will give me the dataset version. If no dataset exists, we'll say it's version 1 of the dataset. Next, we're going to look at the dataset with the previous version and look at the hashes associated with this dataset. I haven't shown you here, but the idea is to create a cat dogs author extracted dataset. My connection isn't very fast, but here goes. In this dataset, we're going to add a tag with the hash associated with all the extracted images. What we do is, if this hash hasn't changed, we won't record a dataset at all. We'd even have to remove the images from the blob store to save space and pay less. On the other hand, if the hash has changed, what we're going to do is register the dataset, which will be linked to our storage space, and position the hash. Quite simply, this means that if the data has changed, this dataset will be created, and only in this case. Next step is that I've added a labeling directory. What's going to happen is this. Ideally, if the hash has changed, you should automatically upload and create a dataset in ECOTAG. Remember, ECOTAG is our labeling application. Here it is. What we want is to automatically create this dataset. We can even automatically create the project with our associated tags. That's exactly what we want. I can't do that today because ECOTAG only requires application accounts. But almost everything has been automated. For the moment, all I've had to do is launch it from my workstation. What I've done is to create a little script, which we'll call an API, the ECOTAG API. I'll ask ChatGPT to generate all the code. That's what saved me so much time. The idea here is that we'll download the dataset associated with our images. In this case, we'll connect to our server, create the dataset to upload the images and lock our dataset, as we did in the previous episode, but by hand, and create the project, launch the associated tags, and start the project. All automatically. If you want to do it, it should be done automatically from AzureML. Today, ECOTAG doesn't allow you to make accounts between computer and computer. However, you can do it today with a user account. If you run this script here, you need to configure the name of your resource group, the workspace, and the version of the dataset to be dynamically injected. Here, there's a notion of JWT token, which corresponds to temporary user access tokens. You can retrieve one here by clicking on Access Tokens. You can copy and paste this access token, which you really shouldn't share with anyone. When the video is published, this access token will be completely invalid. You can put it here and then run this file. I'm not going to do that because there are over 30,000 files and it's going to take a very long time. But today it's automated and it works. The only thing I'm missing is the fact that I have to launch it by hand with my own account. It's a token that corresponds to Bob Smith, but you'd need an application account system between applications. What else can I tell you? http://localhost 5010. Well, there you go. That's about it for this episode. In any case, it works. The idea is really to automate most of your actions. What happens is that you can play with datasets as input, but at the start of the project, of course, start with small batches of data. In other words, in AzureML, don't create a gigantic dataset with PDFs. Start with 10 PDFs that will enable you to set up the entire pipeline, etc. One last thing. When it comes to authentication, I had to change the authentication mode that last time because the access tokens are too short, which means that the AzureML pipeline fails because after a while the token expires and you lose your rights. So if you had made a fork from MLOps Python demo, you'll have to fork again, a new one, because I've changed the way I create a credential that injects itself into AzureML. This way of authenticating is a little less secure, but allows AzureML pipelines to be played completely. Of course, all the code I've presented today is available in one for the request that I'm going to merge, but which will remain available to see all the changes associated with this episode. I think that's quite a lot for this episode. And I'll see you soon. Thank you. See you soon for more videos.